Hi everyone. Today we are going to discuss about hybridization concept. So first of all, what is meant by hybridization? Next, SP and SP2 hybridizations. So hybridization concept, SP and SP2 hybridizations are completed in previous class. So next one, SP3 hybridization. SP3 hybridization. So first one is SP hybridization, second one SP2 hybridization, and third one is SP3 hybridization. So what is meant by SP3 hybridization? Okay. So first of all, best example of SP3 hybridization, that is methane formula CH4. So in methane, central atom is carbon. And carbon atomic number 6. And electron configuration is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. And outermost electron configuration is 2s2, 2p2. Okay. So first of all, one s orbital. Next p orbitals. So p orbitals are 3, px, py, pz. So next 2s2, 2 electrons. Same 2p2, 1 and 2 electrons. Then first excitation state. So 2s orbital electron enter into 2pz orbital. 2s orbital electron enter into 2pz orbital. 1, 2, 3. So in methane, central atom is carbon atomic number 6, electron configuration 1s2, 2s2, 2p2, and outermost electron configuration 2s2, 2p2. So s orbital 1, p orbitals are 3, 2s2, 2 electrons, 1 and 2. Next, first excitation state. 2s orbital electron enter into 2pz orbital. So 2s1, 2px1, 2py1, 2pz. So 1s orbital and 3 p orbitals. So 1 plus 3, 4. 1s orbital, yes, 3 p orbitals, 3 p orbitals. So 4 moles of SP3 hybrid orbitals. So finally, SP3 hybridization means the intermixing of 1s orbital, and 3 p orbitals. The intermixing of 1s orbital and 3 p orbitals of outermost shell of an atom is called SP3 hybridization. So the intermixing of 1s orbital and 3 p orbitals of outermost shell of an atom is called SP3 hybridization. Clear? So the intermixing of 1s orbital and 3 p orbitals of outermost shell of an atom is called SP3 hybridization. And next one, hydrogen. So hydrogen atomic number 1. And electron configuration is 1s1. So s orbitals only 1 and only 1 electron. So every hydrogen has a 1 unpaired electron, and total hydrogen atoms are 4 and total unpaired electrons are 4. Clear? So first of all, carbon, 4 sp3 hybrid orbitals. First one, second one, third one, fourth one. 4 sp3 hybrid orbitals. 4 moles of sp3 hybrid orbitals. Next, 4 hydrogen atoms. So hydrogen atom only s orbital. So first mole hydrogen atom, second hydrogen atom, third hydrogen atom, fourth hydrogen atom. First of all, carbon, C. Next, hydrogen. Next, hydrogen. Next, hydrogen. Next, hydrogen. CH4. And this is sigma sp3 s bond. Same sigma sp3 s bond. sp3 hybrid orbital s orbital. Sigma sp3 s bond. Same sigma sp3 s bond. And fourth one, sigma sp3 s bond. So 4 moles of sigma sp3 s bonds. So first one SP3 hybrid orbital S orbital sigma sp3s. Second one SP3 hybrid orbital S sigma sp3s. Same sigma sp3s. Same sigma sp3s. So this is orbital structure of methane. Methane formula CH4. And finally shape of the molecule. Shape of the molecule. Tetrahedral shape. Tetrahedral shape. And bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. And final structure of methane, central atom is carbon. Remaining 4 hydrogen atoms. First hydrogen atom, second hydrogen atom, third hydrogen atom, fourth hydrogen atom. So this is methane structure CH4. And bond angle is 109 degrees 28 minutes. 28 minutes. Okay. So this is SP3 hybridization. So first of all, what is meant by SP3 hybridization? The intermixing of an s orbital and 3 p orbitals of outermost shell of an atom is called SP3 hybridization. And best example of SP3 hybridization is methane. Methane formula CH4. So in methane central atom is carbon. Carbon atomic number 6. And electron configuration 1s2, 2s2, 2p2. So outermost electron configuration 2s2, 2p2. Then first excitation state 2s orbital electron enter into 2pz orbital. So 1, 2, 3, 4. So 1s orbital, 3 p orbital. So total 4 moles of sp3 hybrid orbitals. And next one hydrogen atomic number 1 electron configuration 1s1. So first of all central atom carbon and 4 sp3 hybrid orbitals. So next s orbitals and 4 moles of sigma sp3s bonds. And shape of the molecule tetrahedral shape and bond angle is 109 degrees 28 minutes. Okay, so in sp hybridization shape of the molecule linear and bond angle is 180 degrees. In SP2 hybridization shape of the molecule tripolar planar and bond angle is 120 degrees. In SP3 hybridization shape of the molecule tetrahedral and bond angle is 109 degrees 28 minutes. So this is SP3 hybridization. SP3 hybridization. So main structure, next tetrahedral and bond angle, that is 109 degrees 28 minutes. 109 degrees 28 minutes. So next. So hybridization. Next SP hybridization, SP2 hybridization. Next one SP3 hybridization. Okay? SP2, SP3. Next study. SP3D hybridization. And next one is SP3D hybridization. SP3D hybridization. Next one SP3D hybridization. So best example of SP3D hybridization, that is PCl5, phosphorus pentachloride. Formula PCl5. So in phosphorus pentachloride, central atom is phosphorus. Phosphorus atomic number 15. And electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3. 1s2, 2s2, 2p6, 3s2, 3p3. So and 3d0. Okay. And outermost electron configuration is 3s2, 3p3, 3d0. Outermost electron configuration is 3s2, 3p3, 3d0. Right. So s orbital only 1. P orbitals are 3. Px, py, pz. And d orbitals are 5. dxy, dyz, dzx, dx square, y square, dz square. So 3s2, 2 electrons. 3p3, 1. 2, 3, 3d0, there is no electrons. No electrons. So 3s2, 2 electrons, 3p3, 3 electrons, 3d0. Then first excitation state. Then 3s orbital electron enter into 3d orbital. So very simple. 3s1, 3p3, 3px1, 3py1, 3pz1, 3p3. Next 3d1. Okay. So 3s orbital electron enter into 3d orbital. So total orbital electrons are 1, 2, 3, 4, 5. The intermixing of 1s orbital. Next 3 p orbital. 1 s orbital, 3 p orbital, and 1 d orbital. 1 d orbital. So 1 s orbital, next 3 p orbitals and 1 d orbital. 1 s orbital s, 3 p orbitals p3, 1 d orbital d. 1 plus 3 4, 4 plus 1 5. So 5 moles of SP3D hybrid orbitals. 5 moles of SP3D hybrid orbitals. 1 s orbital, 3 p orbitals, 1 d orbital. Total 5 moles. S orbital, 3 p orbitals, 1 d orbital. So 5 moles of SP3D hybrid orbitals. So what is meant by SP3D hybridization? Very simple. The intermixing of 1 s orbital, and 3 p orbitals. The intermixing of 1 s orbital, 3 p orbitals, and 1 d orbital. The intermixing of 1 s orbital, 3 p orbitals, and 1 d orbital of outermost shell of an atom is called SP3D hybridization. Okay, so the intermixing of 1 s orbital, 3 p orbitals, and 1 d orbital of outermost shell of an atom is called SP3D hybridization. Okay, so phosphorus atom close. And next one, chlorine. Chlorine atomic number 17. And the electron configuration of chlorine atom: 1s2, 2s2, 2p6, 3s2, 3p5. And outermost electron configuration is 3s2, 3p5. So s orbital only 1 and p orbitals are 3, px, py, pz. Clear? So 3s2, 2 electrons, 3p5, 1, 2, 3, 4, 5. So every chlorine has a 1 unpaired electron. So every chlorine atom has a 1 unpaired electron, and total chlorine atoms are 5, and total unpaired electrons are 5. Okay, and final structure, very important and very simple. First of all, actually complete dotted lines. Okay, dotted lines. And central atom is phosphorus. And 5 SP3 hybrid orbitals. So first SP3D hybrid orbital, second SP3D hybrid orbital, next third mole SP3D hybrid orbital, next fourth one SP3D hybrid orbital, next fifth one SP3D hybrid orbital. Close. 5 moles of SP3D hybrid orbitals. Next 5 chlorine atoms. Every chlorine has a 1 unpaired electron, that is pz orbital. So first orbital of pz orbital, next same second pz orbital of chlorine atom, next third pz orbital of chlorine atom, next fourth pz orbital of chlorine atom, next fifth pz orbital of chlorine atom. So PCl5 structure, phosphorus pentachloride. And shape of the molecule, trigonal bipyramidal. And bond angles are 90 degrees and 120 degrees. So central atom phosphorus. 5 SP3D hybrid orbitals. First one, second one, third one, fourth one, fifth one. Next, total chlorine atoms are 5 chlorine atoms. So first pz orbital of chlorine atom, next pz orbital of second chlorine atom, pz orbital of third chlorine atom, pz orbital of fourth chlorine atom, pz orbital of fifth chlorine atom. And shape of the molecule trigonal bipyramidal, and bond angles are 90 degrees and 120 degrees. So finally structure, very simple. Same. So central atom phosphorus, 5 chlorine atoms, first chlorine, second chlorine, third chlorine, fourth one, fifth one. So shape of the molecule trigonal bipyramidal, and bond angles are 90 degrees and 120 degrees. So this is SP3D hybridization. Okay. So what is meant by SP3D hybridization? And best example of PCl5 and PCl5 phosphorus and chlorine, and structure of PCl5 trigonal, bipyramidal. Next bond angles are 90 degrees and 120 degrees, and PCl5 structure. So this is SP3D hybridization. Close. Okay. Next one. Next one. SP3D2 hybridization. SP3D2 hybridization. SP3D2 hybridization. And best example of SP3D2 hybridization, that is sulfur hexafluoride, SF6. Sulfur hexafluoride. Okay. So best example of SP3D2 hybridization, that is sulfur hexafluoride. So in sulfur hexafluoride, central atom is sulfur. So sulfur atomic number 16, phosphorus atomic number 15, and sulfur atomic number 16. Electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4, and 3d0. 3d0. So total electrons are 16. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 4 16. Next to 3d0. And outermost electron configuration is 3s2, 3p4, 3d0. 3d0. So first of all, s orbital only 1. Next to p orbitals are 3, px, py, pz. Next to d orbitals are 5. Okay, d orbitals are 5. So 3s2, 3p4, 3d0. Next 3s2, 2 electrons. 3p4, 1, 2, 3, 4, 3p4. And 3d0, there is no electrons. There is no electrons. Next, first excitation state. First excitation state, very simple, 3s2, and 3p3, 1, 2, 3. Next 3d1, 3d1. So 3px, 3py, 3pz. 3px electron enter into 3d orbital. Next, second excitation state. First excitation state. Next one, second excitation state. 3s orbital electron enter into 3d2. So very simple. 3s1, 3p3, 1, 2, 3. Next 3d1, 3d2. So 3s orbital electron enter into 3d orbital. So finally, first one, second one, third one, fourth one, fifth one, sixth one. 6 unpaired electrons. So the intermixing of 1s orbital. Next 3 p orbitals. Next 2 b orbitals, b2. The intermixing of 1s orbital. Next 3 p orbitals and 2 d orbitals of outermost shell of an atom is called SP3D2 hybridization. So first 1, 2, 3, 4, 5, 6. So 6 moles of SP3D2 hybrid orbitals. Clear? So first of all, central atom sulfur, atomic number 16, electron configuration 1s2, 2s2, 2p6, 3s2, 3p4, 3d0. And outermost electron configuration 3s2, 3p4, 3d0. So 3s2, 2 electrons, 3p4, 4 electrons, 3d0, there is no electrons. Then first excitation state. So 3p orbital electron enter into 3d orbital. So 3s2, 3p3, 3d1. Next second excitation state. 3s orbital electron enter into 3d orbital. So 1, 2, 3, 4, 5, 6. So the intermixing of 1s orbital, 3 p orbitals, 2 d orbitals of outermost shell of an atom is called SP3D2 hybridization. And total 6 moles of SP3D2 hybrid orbitals. And next to fluorine atom. So fluorine atomic number 9. And electron configuration is 1s2, 2s2, 2p5. 1s2, 2s2, 2p5. And outermost electron configuration 2s2 2p5, 2s2 2p5. So s orbital only 1 and p orbitals are 3, px, py, pz. So 2s2 2 electrons, 2p5 1 2 3 4 5. Every fluorine has a 1 unpaired electron. So total fluorine atoms are 6. So total unpaired electrons are 6. Okay. So first of all, central atom, that is sulfur. Okay, central atom sulfur. Central atom is sulfur. Next, total 6 moles of SP3D hybrid orbitals. 6 moles of SP3D hybrid orbitals. First one. Second mole SP3D hybrid orbital. Next, third mole SP3D hybrid orbital. Fourth one SP3D hybrid orbital. And fifth mole SP3D2 hybrid orbital, sixth mole SP3D2 hybrid orbital. Okay, so 1, 2, 3, 4, 5, 6. Next, total fluorine atoms are 6 fluorine atoms. So pz orbital of first fluorine atom, pz orbital of first fluorine atom. Next, pz orbital of second fluorine atom, pz orbital of second fluorine atom. Next, pz orbital of third fluorine atom, pz orbital of third fluorine atom, pz orbital of third fluorine atom, pz orbital of third fluorine atom. Next, pz orbital of fourth fluorine atom. Next, pz orbital of fifth fluorine atom. Next, pz orbital of sixth fluorine atom, pz orbital of sixth fluorine atom. Okay, so this is structure of sulfur hexafluoride, and shape of the molecule is octahedral, and bond angles are 90 degrees and 180 degrees. Okay, so SF6 sulfur hexafluoride, and shape of the molecule octahedral shape. First of all, 6 moles of SP3D2 hybrid orbitals. So first one, second one, third one, fourth one, fifth one, sixth one. Next, fluorine atom, 6 fluorine atoms. So pz orbital of first fluorine atom, pz orbital of second fluorine atom, third one, fourth one, fifth one, sixth one. And shape of the molecule octahedral, and bond angles are 90 degrees and 180 degrees. And finally, structure is very simple. Sulfur hexafluoride, central atom sulfur, 2 fluorine atoms, first fluorine atom, second fluorine atom, next third one, fourth one, fifth one, and sixth one. Shape of the molecule is octahedral shape. So this is SP3D2 hybridization. Okay, so example SF6, central atom sulfur, and electron configuration, first excitation state, second excitation state, and total 6 moles of SP3D2 hybrid orbitals. Next, fluorine atom, atomic number 9, electron configuration 1s2, 2s2, 2p5, and every fluorine has a 1 unpaired electron, and total fluorine atoms are 6. So 6 moles of SP3D2 hybrid orbitals. Next, pz orbital of fluorine atoms, and shape of the molecule octahedral, and bond angles are 90 degrees and 180 degrees. And final structure of SF6, that is octahedral shape. So hybridization, what is meant by hybridization, and types of hybridizations. So SP, SP2, SP3, SP3D, and SP3D2. Okay, right. So first one SP, second SP2, third SP3, fourth one SP3D2, SP3D, fifth one SP3D. Okay. So first one is SP hybridization. First one is SP hybridization. Second one SP2. Third one SP3 hybridization. Fourth one SP3D hybridization. Fifth one SP3D2 hybridization. Okay. So best example of SP hybridization, that is beryllium chloride, BeCl2. SP2 best example BCl3 or BF3. SP3, best example methane, formula CH4. SP3D, best example of SP3D, PCl5. Next SP3D2, SF6, sulfur hexachloride. Sulfur hexachloride. Okay. And beryllium chloride, shape of the molecule linear. In SP hybridization, shape of the molecule linear. SP2 trigonal planar. In SP3 hybridization, shape of the molecule tetrahedral. Next, in SP3D hybridization, trigonal bipyramidal. And next one, in SP3D2, shape of the molecule octahedral. Okay, octahedral. So linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. And in SP hybridization, bond angle is 180 degrees. 180 degrees. In SP2 hybridization, bond angle is 120 degrees. In SP3 hybridization, bond angle is 109 degrees 28 minutes. In SP3D hybridization, bond angles are 90 degrees and 120 degrees. In SP3D hybridization, bond angles are 90 degrees and 180 degrees. 180 degrees. So see hybridization concept. Okay. So SP, SP2, SP3, SP3D, SP3D. So best example of SP hybridization, beryllium chloride. Best example of SP2 hybridization, boron trichloride. SP3 hybridization, methane. SP3D, PCl5. SP3D2, SF6. So in SP hybridization, shape of the molecule linear and bond angle is 180 degrees. SP2 hybridization, shape of the molecule trigonal planar and bond angle is 120 degrees. SP3 hybridization, shape of the molecule tetrahedral and bond angle is 109 degrees 28 minutes. In SP3D hybridization, shape of the molecule trigonal bipyramidal and bond angles are 90 degrees and 120 degrees. In SP3D2 hybridization, shape of the molecule octahedral and bond angles are 90 degrees and 180 degrees. So this is S hybridization concept. SP, SP2, SP3, SP3D and SP3D2. Okay? Right. Next. Next, ammonia. Next, ammonia. Generally, ammonia formula NH3. Ammonia formula NH3. So in ammonia, central atom is nitrogen. Ammonia formula NH3. In ammonia, central atom is nitrogen. And nitrogen atomic number 7. And electron configuration is 1s2, 2s2, 2p3. So in ammonia, central atom is nitrogen and nitrogen atomic number is 7. Electron configuration of nitrogen 1s2, 2s2, 2p3. And outermost electron configuration is 2s2, 2p3. 2s2, 2p3. So very simple. S orbital only 1 and p orbitals are 3. px, py, pz. Px, Py, Pz. 2s2, 2 electrons. 2p3, 1, 2, 3. 3 electrons. Okay? So nitrogen close. Next one, hydrogen. Generally, hydrogen atomic number 1. Electron configuration is 1s1 and every hydrogen has a 1 unpaired electron. So total hydrogen atoms are 3. First hydrogen atom, second hydrogen atom, third hydrogen atom. So first bond formation, second one, third one. So in ammonia, central atom is nitrogen. Ammonia central atom is nitrogen. And remaining 3 hydrogen atoms. So 3 bond pairs. First hydrogen atom, second hydrogen atom, third hydrogen atom. And next one is lone pair. This is lone pair. So in ammonia, central atom is nitrogen. And 3 hydrogen atoms. 1, 2, 3. And nitrogen has a 1 lone pair. 1 lone pair. Nitrogen has a 1 lone pair. And shape of the molecule is pyramidal shape. Shape of the molecule pyramidal. And hybridization is SP3 hybridization. And bond angle is very important, 107 degrees. Approximately 107 degrees. So actually in ammonia, so nitrogen undergoes SP3 hybridization. In sp3 hybridization, actually shape of the molecule tetrahedral, but in ammonia shape of the molecule is pyramidal due to repulsions between lone pair and bond pairs. Lone pair and bond pairs. So in ammonia, nitrogen undergoes sp3 hybridization. In sp3 hybridization, actually shape is tetrahedral, but in ammonia shape of the molecule pyramidal. But in ammonia shape of the molecule pyramidal due to repulsions between lone pairs and bond pairs. Due to repulsions between lone pairs and bond pairs. Okay. So in ammonia central atom is nitrogen, and nitrogen undergoes sp3 hybridization. In sp3 hybridization, actually shape is tetrahedral, but in ammonia exists shape is pyramidal shape due to repulsions between lone pair and bond pairs. Lone pair and bond pairs. So shape of the molecule pyramidal shape, and bond angle is 107 degrees. 107 degrees. So this is ammonia. Okay. So in ammonia central atom is nitrogen, atomic number 7, electron configuration 1s2, 2s2, 2p3, outermost electron configuration 2s2, 2p3, hydrogen atomic number 1, electron configuration 1s1, 3 hydrogen atoms. So central atom is nitrogen, first hydrogen atom, second hydrogen atom, third hydrogen atom, and nitrogen has a one lone pair. So shape of the molecule pyramidal, hybridization sp3, and bond angle is 107 degrees. So in ammonia, nitrogen undergoes sp3 hybridization. In sp3 hybridization, actually shape is tetrahedral, but in ammonia exists shape or structure is pyramidal due to repulsion between lone pair and bond pairs. Due to repulsion between lone pair and bond pairs. Okay. So ammonia completed. And next one, water. Next one, water. Next, water. Water formula H2O. H2O. So in water molecule central atom is oxygen. Oxygen atomic number 8. Same electron configuration 1s2, 2s2, 2p4, 2p4. And outermost electron configuration is 2s2, 2p4, 2s2, 2p4. So s orbital only 1 and p orbitals are 3, px, py, pz. 2s2 2 electrons, 2p4 1, 2, 3, 4. Okay, clear. Next, hydrogen atomic number 1. Electron configuration is 1s1. So hydrogen has only one unpaired electron. So two hydrogen atoms, first hydrogen atom, second hydrogen atom. Clear. So in water molecule central atom is oxygen. Remaining two hydrogen atoms, first hydrogen atom, second hydrogen atom. First hydrogen atom, second hydrogen atom. And oxygen has a two lone pairs, first lone pair and second lone pair. So in water molecule, oxygen undergoes same sp3 hybridization. sp3 hybridization, and shape of the molecule V shape or angular shape. V shape or angular shape, and bond angle is same 104.5 degrees. 104.5 degrees approximately. So in water molecule, central atom is oxygen, and oxygen undergoes sp3 hybridization. In sp3 hybridization, actually shape is tetrahedral shape. But in water molecule, existing shape is V shape due to repulsions between lone pair and bond pairs. Repulsion between lone pair and bond pairs. So shape of the molecule V shape, and bond angle is 104.5 degrees. Okay. So in water molecule, central atom is oxygen, and oxygen undergoes sp3 hybridization. In sp3 hybridization, actually shape is tetrahedral shape. But in water molecule, existing shape is V shape due to repulsions between lone pair and bond pairs. So shape of the molecule V shape, and bond angle is 104.5 degrees. 104.5 degrees. So ammonia approximately 107 degrees, and water molecule approximately bond angle is 104.5 degrees. 104.5 degrees. So this is hybridization concept. Okay. sp hybridization, SP2 hybridization, SP3 hybridization, SP3D hybridization, SP3D2 hybridization. Next, ammonia molecule. Next one, water molecule. So in ammonia, nitrogen undergoes SP3 hybridization. Shape of the molecule pyramidal shape, and bond angle is 107 degrees. So in water molecule, oxygen undergoes sp3 hybridization, and shape of the molecule V shape, and bond angle is 104.5 degrees. 104.5 degrees. So this is hybridization concept. Okay. So hybridization concept completed. Then next topic, very important topic. Next topic. is hydrogen bond. Hydrogen bond. So what is meant by hydrogen bond? What is meant by hydrogen bond? Covalent bond, ionic bond, next one hydrogen bond. What is meant by hydrogen bond? Very simple. The weak electrostatic forces of attractions. The weak electrostatic forces. The weak electrostatic forces of attractions. The weak electrostatic forces of attractions between hydrogen atom and more electron negativity atoms. That is fluorine, oxygen, nitrogen, etc. So it's called hydrogen bond. So first of all, what is meant by hydrogen bond? The weak electrostatic forces of attractions. The weak electrostatic forces of attractions between hydrogen atom and more electronegativity atoms like fluorine, oxygen and nitrogen is called hydrogen bond. And it is represented by dotted lines. Okay. So first of all, what is meant by hydrogen bond? Very important definition. The weak electrostatic forces of attractions. The weak electrostatic forces of attractions between hydrogen atom and more electronegativity atoms like fluorine, oxygen and nitrogen is called hydrogen bond. And it is represented by dotted lines. Okay. And further, hydrogen bonds classified into two types. So types of hydrogen bonds. First of all, what is meant by hydrogen bond? Next, types of hydrogen bonds. So first one is intermolecular hydrogen bond. Intermolecular hydrogen bond. And second one, intramolecular hydrogen bond. Intramolecular hydrogen bond. So types of hydrogen bonds. So first one is intermolecular hydrogen bond, and second one is intramolecular hydrogen bond. Inter, intra, I-N-T-R-A. So intermolecular hydrogen bond, intramolecular hydrogen bond. So first one subheading, that is intermolecular hydrogen bond. So what is meant by intermolecular hydrogen bond? Intermolecular hydrogen bond. Okay. First of all, what is meant by hydrogen bond and types of hydrogen bonds? So two types: intermolecular hydrogen bond, next intramolecular hydrogen bond. Then first one subheading, that is intermolecular hydrogen bond. So what is meant by intermolecular hydrogen bond? So very simple. A hydrogen bond formed between two molecules. A hydrogen bond formed between two molecules is called intermolecular hydrogen bond. So intermolecular hydrogen bond means a hydrogen bond formed between two molecules is called intermolecular hydrogen bond. Example, water. Water formula H2O, next to hydrochloric acid HF, next to ammonia formula NH3. So these are best example of intermolecular hydrogen bond. So water formula H2O, hydrochloric acid HF and ammonia formula NH3. So first example, water formula H2O, okay? H2O, water H2O. Next to same water molecule formula H2O. Next to same water molecule formula H2O. So hydrogen bond means the weak electrostatic forces of attractions between hydrogen atom and more electronegativity atoms like fluorine, oxygen and nitrogen. So oxygen is one of the electronegativity atom, more electronegativity atom. So hydrogen atom between hydrogen atom and more electronegativity atom, that is oxygen atom. So this is hydrogen bond. So already chapter clear. It is represented by dotted lines. Dotted lines. So dotted lines. Next, hydrogen atom, and more electron negativity atom. That is oxygen. So let's say hydrogen bond. So okay, intermolecular hydrogen bond. A bond form or a hydrogen bond form between two molecules is called intermolecular hydrogen bond. And best example of intermolecular hydrogen bond, that is water molecule. Second one, hydrochloric acid. So hydrochloric acid formula HF. Same hydrochloric acid formula HF. Same hydrochloric acid formula HF. Clear. So hydrogen atom and more electron negativity atom, that is fluorine atom. Same hydrogen atom and more electron negativity atom, that is fluorine. Okay. So this is intermolecular hydrogen bond. Here. So finally, intermolecular hydrogen bond means a hydrogen bond formed between two molecules is called intermolecular hydrogen bond. Example, water and hydrochloric acid, ammonia. So water formula H2O, same H2O. So hydrogen atom and more electron negativity atom. So this is intermolecular hydrogen bond. And second example, hydrochloric acid. So hydrogen atom and more electron negativity atom, fluorine. Hydrogen atom and more electron negativity atom. So this is intermolecular hydrogen bond. Okay. So hydrogen bond definition and types of hydrogen bonds. Intermolecular hydrogen bond, next intramolecular hydrogen bond. And first one is intermolecular hydrogen bond. And best example of intermolecular hydrogen bond, that is water, hydrochloric acid and ammonia. Next one, second one, intramolecular hydrogen bond. First one, intermolecular hydrogen bond, and second one is intramolecular hydrogen bond. Intramolecular hydrogen bond. Intermolecular hydrogen bond. Next one, intramolecular hydrogen bond. Intermolecular hydrogen bond. Best example, water, hydrochloric acid and ammonia. And second one is intramolecular hydrogen bond. So what is meant by intramolecular hydrogen bond? Very simple. A hydrogen bond formed within the molecule. A hydrogen bond formed within the molecule. A hydrogen bond formed within the molecule is called intramolecular hydrogen bond. First one, intermolecular hydrogen bond between two molecules. Intramolecular hydrogen bond within the molecule. So a hydrogen bond formed within the molecule is called intramolecular hydrogen bond. And best example, very important best example, that is ortho hydroxy benzaldehyde. Best example of intramolecular hydrogen bond, that is ortho hydroxy benzaldehyde. So intermolecular between two molecules. Intramolecular within the molecule. A hydrogen bond formed within the molecule is called intramolecular hydrogen bond. And best example of intramolecular hydrogen bond, ortho hydroxy benzaldehyde. So first of all, benzaldehyde formula C6H5C double bond OH, benzaldehyde. Next, ortho position, hydroxy formula OH. So ortho hydroxy benzaldehyde. Ortho meta para. So ortho hydroxy benzaldehyde. Formula C double bond OH. So very simple. C double bond OH. C double bond OH. Okay. C double bond OH. Ortho hydroxy benzaldehyde. Ortho hydroxy benzaldehyde. So hydrogen atom and more electron negativity atom, that is oxygen atom. A hydrogen bond formed within the molecule is called intramolecular hydrogen bond. So intermolecular hydrogen bond means between two molecules. Intramolecular hydrogen bond means within the molecule. Example, ortho hydroxy benzaldehyde. hydrogen atom and more electron negative atom. So a hydrogen bond formed within the molecule is called intramolecular hydrogen bond. Okay. So what is meant by hydrogen bond and types of hydrogen bonds? Intermolecular hydrogen bond and intramolecular hydrogen bond. Intermolecular hydrogen bond means between two molecules and intramolecular hydrogen bond within the molecule. Intermolecular hydrogen bond, best example water, hydrochloric acid and ammonia. Intramolecular hydrogen bond, best example ortho hydroxy benzoate. So this is hydrogen bond. Okay, right.